Retaining walls prevent soil from sliding on sloped ground. They protect roads, buildings, bridges, and other structures. Each type is designed to resist earth pressure differently. Engineers study the soil before selecting a retaining wall. The investigation determines the soil strength and groundwater level. This information ensures a safe and economical design. A strong retaining wall starts with a properly prepared foundation. The ground is compacted before the wall is constructed. This prevents settlement and improves stability. Cantilever retaining walls are built with reinforced concrete. The footing and wall work together to resist soil pressure. This design is stronger and uses less concrete than a gravity wall. Gravity retaining walls resist soil pressure using their own weight. Their thick base provides excellent stability. They are commonly used for low to medium height slopes. Counterfort retaining walls are used for very high retaining heights. The counterforts reduce bending forces on the wall. This makes the structure stronger and more economical. Backfill is placed and compacted in thin layers behind the wall. Drainage materials prevent water pressure from building up. Proper backfilling improves the wall's long-term stability. Sheet pile walls are made from interlocking steel sections. They are driven deep into the ground using hydraulic equipment. These walls are ideal near rivers, ports, and deep excavations. The embedded section anchors the wall inside the soil. The interlocking piles resist both earth and water pressure. This keeps deep excavations stable during construction. Water passes freely through the stones inside the gabion wall. This prevents hydrostatic pressure from developing. Excellent drainage greatly increases the wall's durability. Gabion walls are built using wire baskets filled with stones. The heavy rocks resist soil pressure naturally. They are economical and environmentally friendly. MSE walls combine compacted soil with geogrid reinforcement. Each soil layer is strengthened before the next layer is added. The reinforced soil and each geogrid layer reinforces the compacted soil behind the wall, acts as one stable mass under pressure. This allows MSE walls to safely support very high embankments. Anchored retaining walls use steel tendons to resist earth pressure. The anchors transfer loads deep into stable ground behind the wall. This system is commonly used for deep excavations. Crib walls consist of interlocking concrete members filled with stone. The stone adds weight while allowing excellent drainage. They are suitable for stabilizing slopes. Drainage is one of the most important parts of any retaining wall. It removes excess water before pressure builds behind the structure. Proper drainage greatly increases the wall's lifespan. Backfill must be placed in thin layers. Poor compaction can cause settlement. Engineers test every layer before construction continues. Retaining walls are designed to carry both soil and surface loads. Engineers calculate these forces before construction begins. A properly designed wall remains stable even under heavy traffic. The reinforced soil and geogrids work together to carry heavy loads. Instead of one weak point, the load is spread across the entire system. This makes MSE walls one of the strongest walls. Drainage prevents water from building pressure behind the wall. Without proper drainage, even a strong wall can eventually fail. Every retaining wall must include an effective drainage system. Retaining walls are used anywhere soil must be safely supported. They protect infrastructure from landslides and erosion. Different projects require different retaining wall designs.
Every retaining wall has its own advantages and applications. Engineers choose the best type based on soil conditions and loading. The correct design ensures safety and long-term.
Retaining walls design combines structural strength, soil mechanics, and proper drainage. When built correctly, they protect lives, infrastructure, and the environment for decades. Poor drainage and weak foundations are common causes of retaining wall failure. Water pressure and loose soil increase the forces acting on the wall. Proper engineering